Hello and welcome. This video we will try to solve some problems on domain and range for quadratic functions. So let us solve problems of this form, that is ax square plus bx plus c form. So one thing you have to note here is whenever we have a quadratic function of this form f of x is equal to ax square plus bx plus c. So if there is no denominator which has x, then the domain of this function is complete real number, because it's complete real number because you pick any value in the real number and put it inside this f of x, that will give you a definite value. So no value in the real number will give you an undefined value for f of x. So every real number becomes the domain of uh, this function ax square plus bx plus c. So without thinking much, we can directly write domain as real number, or I can also write this as minus infinity to plus infinity. Next, let us find the range. To find the range, so we need let us use the completing square method only. So we have f of x is equal to 2x square plus x minus 6. Here, to apply completing square method, we know the coefficient of x square should be 1. So here the coefficient of x square is 2. So let us make it 1 by taking 2 common. If I take 2 outside, I'll get x square plus x by 2 minus 3. 6 by 2 is 3. So now let us apply the completing square method. X square, so let us take this, I take this as a square, so this is my a square, and plus 2a I'll write here, so 2ab I have to make here. So I'll simply write 2 and x. This is 2 is formulas to, we want this as a. So we have 2a, and we have to put b here. So what is the value of b? Value of b is always half of coefficient of x. So here the coefficient of x is half. So half of half is 1 by 4. This is 1 by 4. So here I can put 1 by 4. So even if you don't want, I can cancel these two and I can get back to the original equation. Then we have found b. Next is b square I have to add. So I have 2ab. Now I want b square. What is b square? B square is 1 by 4 whole square. I've added 1 by 4 whole square. I have to subtract with the same number, 1 by 4 whole square. Plus minus 3 is this number. Okay. So from these three terms, this completes a square. This is a square, this is b square, and this is 2ab. Finally, I can write this as 2 times x plus 1 by 4, x plus 1 by, let me write it correctly, x plus 1 by 4 whole square minus 1 by 16 minus 3. So what I do is, I'll simplify the terms after this, x plus 1 by 4 whole square, x plus 1 by 4 whole square, take minus out to make it simple, plus 3. So this is equal to 2 times x plus 1 by 4 whole square minus, take LCM, 1 plus 16 into 3 is 48, 48 by 16. So this is equal to 2 times x plus 1 by 4 whole square minus 49 by 16. Finally, I'll take 2 inside. I'll multiply 2 both the terms inside the bracket. So I'll get 2 times x plus 1 by 4 whole square minus 2 into 49 by 16. So this is equal to 2 into x plus 1 by 4 whole square 2128 minus 49 by 8. So this is the standard form we have to bring in. So now we have important things to note here. So x, if I equate x plus 1 by 4 to 0, I'll get x is equal to minus 1 by 4. So this is my vertex point. What do you mean by vertex point? At this point, the value of the quadratic polynomial is either maximum or minimum. Let's see. And how does the curve look? So if I have this, the vertex is minus 1 by 4. At this point, we have minus 1 by 4. At minus 1 by 4, the value is, if I put x is equal to minus 1 by 4, you'll get f of minus 1 by 4 is equal to, so this term becomes 0. I'll get minus 49 by 8. Minus 49 by 8 is actually minus 8 6 of 48, 6.125. So what I claim here is, here in this quadratic function, a is 2, which is positive. A is positive, so we know if a is positive, the curve looks up. The value at minus 1 by 4 is minus 6.125. Let us take this as minus 6.125. So what I claim is, this point curve is minimum. This point, so this point is actually minus 1 by 4 comma 6.125, or to be precise, this is minus 0.25 comma 6.125. So since the curve is looking up, the range of this function will be from here to infinity. So I'll write the range. This function, the range of this function is range is f of x greater than or equal to minus 6.125, or I can write minus 6.125 to infinity. Let us verify in the graph plotter. We have a graph plotter here. I want the equation. The equation is 2x square plus x minus 6. 2x square plus x minus 6. So the minimum value is this. So we can see here the minimum point is minus 0.25 and minus 6.125. So this is right. Let us solve another problem. So here here a is 3. So f of x is equal to 3x square plus x. So we'll not worry about the domain of this function, because domain is complete real number. So let us solve this. To find the range, I'll apply completing square method. I have to take 3 outside because the coefficient of x square should be 1. If I take 3 outside, this becomes x square plus x by 3. So 3 into x square plus, write this as 2a b I want. So here the coefficient of x is 1 by 3. So how will I get b? B is half of coefficient of x, which is half into 1 by 3, which is 1 by 6. So here I'll write 1 by 6. So if I cancel this 2, 1, 2, 3, I'll get back to the same original equation. So now I have to add b square, which is 1 by 6 square, minus, I have to add the same thing which I added, minus 1 by 6 square, and there is no c term here, so we can stop here. So from these 3 term I can write this as x plus 1 by 6 whole square minus 1 by 36. So finally what I have to do is I have to bring 3 inside. F of x is equal to 3 into x plus 1 by 6 whole square minus 3 into 1 by 36. Remember, we have to bring this coefficient inside. This is very important. You should not forget to bring the coefficient inside. X plus 1 by 6 whole square minus 3, 1, 3, 12. This is minus 1 by 12. So this is the standard form we have to bring in. Now we have to let us find the vertex of this function. So from here, the value of x is x plus 1 by 6 is equal to 0. If I want this to vanish, I have to put x is equal to minus 1 by 6. So this is my vertex point. Vertex point means the value of f of x is either minimum or maximum over here. What I claim is minus 1 by 6 somewhere here, minus 1 by 6 somewhere here. At this point, the curve looks up like this, and if you put x is equal to 1 by minus 1 by 6, f of minus 1 by 6 is equal to minus 1 by 12. So this goes to 0. So this value is minus 1 by 12. So the range is from here to infinity. So the range of the function, finally, let us write range of the function. The range is minus 1 by 12 to infinity. So this point is minus 1 by 6 comma minus 1 by 12. Let us verify this. The function is 3x square plus x, 3x square plus x, 3x square plus x. So here we have the value. Let us zoom in. This point is minus 0.167, which is 1 by 6, and 0.083 is minus 1 by 12. You can verify if you want. Let us go to the next problem. Now, domain, I can directly write this as range. Domain is real numbers, complete real number. Let us find the range of this function. The range of the function. To find the range of the function, we have to bring this to the standard form. So what I do is, I use again completing square method. It is 3x square plus 12. I'll take 3 out. So I'll get x square plus 4 square plus 4. So this is already in the completing square, already in the standard form, because we don't have any x term here. Whenever we don't have x term, so we need not to proceed further because it's already in the standard form. So what I can write here is, I can write this x minus 0 whole square, x square I can write x minus 0 whole square plus 4. Then I'll take 3 inside, so I'll get 3 times x minus 0 whole square plus 12. So my vertex point here is x minus 0 is equal to 0, which x is equal to 0. So whenever we don't have x, so the vertex point is always x is equal to 0. So if I plot, so my vertex point is this 0, and if you put f of 0, so you'll get 3 times 0 plus 12, which is 12. So somewhere here I'll take 12, and I claim the curve looks up like this. So the range will be f of x greater than or equal to 12, or you can take from 12 to infinity. Let us verify. Function is 3x square plus 12. It's gone up. And see, this is going from 12 to infinity. So that is the range of the function. To solve next problem, I have f of x is equal to x square minus 16. This is already in the standard form. Domain is complete real number. Let us find the range. To find the range, I have to apply completing square method to bring it in the standard form. X square minus 16. So there is the coefficient of x square is already 1. There is nothing much we have to do here. So I can simply write this as x minus 0 whole square minus 16. So here the vertex point is x is equal to 0. So if you plot this at 0, we have the vertex point. If you find what is f of 0, you'll get minus 16. So the curve at 0 takes the minimum value, which is minus 16. Since coefficient of f is positive, the curve looks up like this. So the range of this function is from minus 16 to infinity. Range of this function is f of x greater than or equal to minus 16, or I can write minus 16 to infinity. Let us verify this. X square minus 16. You can see this point is minus 16 to infinity. Now let us try to solve the next class of problems. So here, this is an important problem because the coefficient of x square is negative 1 here. Anyhow, domain remains same. Domain is complete real number. Let us try to find the range. To find the range of the quadratic function, let us apply completing square method f of x. I have f of x is equal to